All right, class. Just a couple of more examples on this section. This section, particularly, there isn't a whole lot more that we need to learn on this. Section 5.2 actually should have gone with 5.1, but they just want you to separate the differences here between GCF and grouping. So once again, the idea is the same. You take a look at all of your terms right there, trying to figure out whether you have a GCF in common or not. So don't get fooled into thinking that because it has four terms, it's always going to be factoring by grouping. No, you always have to check. So make sure that you check first before you start dealing with grouping. So let's take a look at this particular example here. We have four terms, and if we take a look, we have first start off with the coefficients, the 20, the 12, 25, and the 15. Well, if we take a look here, the 20, the 25, and the 15, well, they're factors of 5. But in this case, we cannot factor out a 5 because 5 is not divisible into 12. The same thing with the variable. All of these have the variable x, but this one doesn't. So once again, this is a perfect candidate for factoring by grouping. So we're going to go ahead and take a look at this. And in this particular case, we're going to go ahead and take a look at the first pair. So we're going to go ahead and take a look at these two. And then we're going to pair off the last two. So just ignore the second part there. You have 20 and 12. So the GCF, once again, we're trying to figure out the largest number divisible into both of those. In this case would be 4. But we also have to factor out the variable. Both of them have x in common, so you factor out the smallest power. So the GCF for these two is going to be 4x third. So 20 divided by 4 will be 5. If you factor out x to the third from x to the 6, you're taking it away, so that'll be x to the third. Negative 12 divided by 4 is negative 3. And you factor out x to the third, so we're left with that. And do the same thing for the second pair. In this case, the negative 25 plus the 15, both of them have the 5 in common. You don't have a variable in common, so the only thing that we're going to factor out is the negative 5. And hopefully we end up with the same polynomial as what we had for the first pair. So negative 25 divided by negative 5 is positive 5 x to the third, and positive 15 divided by negative 5 will give you negative 3. So once again, it does give you the same polynomial that we had for the first pair, and that's what you're going to factor out for the first pair, for the whole thing as well. So we're going to factor out the 5x to the third minus 3. So we're going to factor it out from there. So we're factoring it out from the first term. So that'll be 4x to the third. And we're factoring out from the negative 5. So that's what we have left. Once again, when you're doing this, make sure that you first initially see if there's a common factor for all of them. If there isn't, then you're going to go ahead and group them just the way we've been doing. All right, our next example, number 10. And once again, this comes from your additional exercises. So if you're wondering where these problems coming from, they're coming from this one, section 5.2 additional exercises. So once again, if you haven't printed them out or saved them, right now it should be a good thing to go ahead and do that first. But once again, if you take a look at number 10 there, they don't share a common factor as far as the GCF here. You have 2, essentially you have a 1 in front of this y. You have negative 2 and you have negative 1. All right, and the same thing with a variable. They don't share a common variable. So we're going to pair off these two and we're going to pair off these two. Now, as far as what we're going to factor out, it's a little bit more subtle here. For the first pair, we know for sure we're going to factor out the y. There isn't a common number, so the only thing that we're going to do is factor out the y from this one. So we're left with 2x. And in this case, since we don't have a coefficient here and we're going to completely factor out the y, I would suggest for you to put a 1 there. So when we factor out the y, we have plus 1 right there. So once again, hopefully we end up with the same thing for the next one. Now, it's a little bit tricky for the next one. You have negative 2x minus 1. Initially, it looks like nothing is divisible into both of them. But if you look closely, this almost looks very similar to this, except that the signs are different. So sometimes what you're going to have to do here is you're going to have to factor out a 1. And in this case, it'll be a negative 1. And yes, you could do this. All right, you could